Now I have all the verified data I need. Writing the script. An unglazed terracotta pot costs $1.98 at Home Depot. That same pot, filled with water and placed in the right position in a room, will reduce the ambient air temperature in its immediate zone by between 8 and 14 degrees Celsius, without consuming a single watt of electricity, without a refrigerant that degrades and requires recharging, and without a monthly bill that climbs every summer you own it. This is not a claim from a wellness blog. This is the documented result of peer-reviewed laboratory testing published in the journal Experimental Heat Transfer by S. Alpha Head and colleagues in 2014, who ran unglazed pottery arrangements through a wind tunnel simulating Kuwait summer conditions of 40 to 48 degrees Celsius and measured consistent air temperature drops across every test configuration. A review study published on ResearchGate in 2023 analyzed the accumulated global research on pot and evaporative clay systems and confirmed that, on average, these systems lower ambient temperature between 8 and 18 degrees Celsius, with the highest results occurring in dry climates with low relative humidity. The mechanism is called direct evaporative cooling. Unglazed terracotta is a porous ceramic material. Water stored inside the pot migrates through the clay walls via capillary action and reaches the outer surface. On contact with the surrounding air, that water evaporates. Every gram of water that transitions from liquid to vapor absorbs 2,260 joules of thermal energy from the air it touches. That energy is heat. The air surrounding the pot becomes cooler. If you position the pot near a window where natural airflow moves across its surface, or place it in front of a small fan, the rate of evaporation increases, and the cooling effect scales with it. You are not generating cold air. You are physically removing heat from the room through the thermodynamics of phase change. It is the same principle that makes perspiration the most efficient thermal regulation system biology ever produced. The global HVAC market was valued at $263.6 billion in 2023, according to BCC Research. The dominant technology in that market is the compressor-based air conditioning unit, a machine that costs between $300 and $5,000 to purchase, requires professional installation, depends on hydrofluorocarbon refrigerants classified as potent greenhouse gases under EU F-gas regulations updated in 2024, and consumes an average of 500 to 3,000 watts of electricity per hour of operation. According to the U.S. Energy Information Administration, air conditioning accounts for roughly 12% of total energy consumption in American homes. A single window unit running 8 hours a day across a 120-day summer adds between $77 and $138 to the annual electricity bill every year until the unit is replaced. An unglazed terracotta pot is not patentable. There is no recurring revenue attached to it. No company profits from your refilling it with tap water each morning. It sits at the absolute margin of a $263 billion industry, and the logic of that market provides all the explanation needed for why it receives no advertising budget and no position in any home improvement retailer's seasonal display. The oldest documented use of this principle comes from North Africa. Archaeological evidence indicates that evaporative cooling using porous clay vessels was practiced in ancient Egypt as far back as 2500 BCE. Frescoes from residential and palace structures of the period show servants fanning large clay water jars to accelerate surface evaporation. The cooling produced was not incidental. It was the purpose of the arrangement. The Rolex Awards Foundation, in their documentation of Mohammed Bah Abba's work, explicitly notes that his pot device was based on a principle of physics already known in ancient Egypt. The Egyptians built their summer survival strategy around the same material that now sits in the garden section of your nearest hardware store for under $2. Persian engineers took the principle and scaled it into architecture. The badgir, or windcatcher, is a tower structure built above a building to capture prevailing winds at height and direct them downward through interior channels across water or wet clay surfaces at ground level. The earliest confirmed badgir towers date to approximately 1300 BCE in what is now Iran. The city of Yazd, located in one of the hottest and driest regions of the Iranian plateau, has more than 1,000 badgir structures still standing and still functioning. Persian builders understood that the physics of evaporative cooling did not require sophisticated materials or external energy input. It required porous clay and moving air. They scaled that insight into civic infrastructure that has outlasted every piece of mechanical cooling equipment ever manufactured. In India, the same understanding produced the matka, an unglazed clay pot used continuously for water storage and cooling across millennia. Water stored in a matka is consistently 10 to 15 degrees Fahrenheit cooler than the surrounding air, a result that reflects the ongoing evaporation through the pot's porous walls. The matka is not a historical artifact. It is sold in every Indian market today for the equivalent of 60 cents to $2 and is used in tens of millions of households as the preferred method for storing drinking water in warm climates. In 1995, a Nigerian teacher named Mohammed Bah Abba began distributing a device he called the pot-in-pot preservation system to rural farmers in Jigawa State, northern Nigeria. The device used two unglazed clay pots of different sizes. The smaller pot sat inside the larger one. Wet sand filled the gap between them. A damp cloth covered the top. Time magazine named it one of the best inventions of 2001. Eggplants stored inside the inner pot remained fresh for 27 days, compared to the standard 3 days at ambient temperature in that climate. Tomatoes and peppers lasted up to 3 weeks. In 1992, Nigerian professor Victor Imiuwu had already conducted laboratory measurements at the University of Benin City, confirming that a two-pot clay arrangement could maintain interior temperatures up to 14 degrees Celsius cooler than the surrounding environment. Bah Abba took that measured data and distributed 5,000 units in the first production run. He received the Rolex Award for Enterprise in 2000. He used the $75,000 prize to expand distribution across 11 northern Nigerian states and into Cameroon, Niger, Chad, and the Democratic Republic of Congo. In the description, you will find a complete breakdown of the configurations that maximize cooling output for different room sizes, humidity levels, and climates, including the specific pot arrangements that the Alpha Head study found most effective under high heat conditions. Here is the exact setup. You need one unglazed terracotta pot, 8 to 12 inches in diameter. Unglazed means the exterior is matte, slightly rough to the touch, and does not have a shiny sealed coating. Glazed terracotta has a fired surface finish that blocks water migration and produces no evaporative cooling effect. Unglazed pots are sold in the garden section at Home Depot, Lowe's, and Walmart. The Pennington 8-inch terracotta classic pot is available at Home Depot for $1.98. Comparable unglazed garden pots at Walmart range from $1.74 to $2.47, depending on size. You also need a shallow clay or ceramic saucer to sit under the pot and catch any water that seeps through the bottom. Fill the pot with clean water. Set it on the saucer. Place it near a window that receives cross ventilation, or position it directly in front of a small fan. The surface of the pot will begin cooling immediately as evaporation starts. In a room with relative humidity below 50%, the ambient air temperature near the pot will drop measurably within 20 to 30 minutes. Refill the pot once every 24 hours. In very hot and dry conditions, it may need refilling more frequently as evaporation accelerates. For larger rooms, use 3 to 5 pots arranged in a row in front of an open window or a fan. The total evaporative surface area scales proportionally with the number of pots. 5 10-inch terracotta pots represent a total material cost of under $12 and zero ongoing cost beyond tap water. For maximum performance in any climate, stagger the pots slightly rather than placing them in a straight line. The Alpha Head study found that a staggered arrangement produced a larger temperature drop than an aligned one at the same airflow rate, because the staggered configuration exposes more surface area to the moving air. This technique performs at its highest in low humidity environments. Phoenix, Denver, Las Vegas, Albuquerque, and all high-altitude dry climates in the American West will see the full 8 to 14 degrees Celsius reduction. The Persian engineers who built the badgirs of Yazd were working in exactly this type of climate. In regions where summer humidity regularly exceeds 65 to 70%, the rate of evaporation slows because humid air has limited capacity to absorb additional moisture. The Gulf Coast, Southeast, and Midwest during peak summer humidity will see reduced results, perhaps 3 to 5 degrees of temperature drop rather than 14. The pot's outer surface remains cooler than ambient in those climates regardless, providing some radiant cooling benefit even where the full evaporative effect is limited. The cost comparison is simple. A window air conditioning unit for a 200 square foot room costs $150 to $400. It runs on electricity at a rate that adds $77 to $138 to your bill each summer season. It uses a refrigerant that requires periodic servicing. 5 terracotta pots cost $10 once. The water to fill them for an entire summer costs less than $3. There is no installation. There is no service contract. There is no refrigerant. There is no bill. The Egyptians documented this principle at Amarna before most written records existed. Persian engineers in Yazd built cooling infrastructure around it that has functioned without maintenance or power for over 3,000 years. Indian households have used the unglazed clay matka continuously across civilizations without interruption. Mohammed Bah Abba formalized the physics into a distributable device that extended food shelf life for farmers across 11 Nigerian states, and was independently verified by a laboratory at the University of Benin City a full 3 years before his first production run. None of these groups needed a patent, a refrigerant certification, or a utility connection. They needed porous clay and water, and the understanding that evaporation moves heat. That understanding is sitting on a shelf in the garden section for $1.98. If this changed how you think about what you already have access to, subscribe and share it with someone paying too much to stay cool this summer.